Hello dear students, welcome to my physics channel physicsrnt. Today we are going to solve some multiple choice questions from surface tension. These questions have been asked in various medical and engineering entrance examinations. At first, let us review the related formulas and tips. From Ascent formula, H is equal to 2t cos theta upon r rho g, where H is the rise height of liquid in the capillary, T is surface tension, theta is angle of contact of liquid, r is radius of capillary, rho is the density of liquid. Second, surface energy sigma is equal to work done upon change in area, which is numerically equal to surface tension T. Third, wetting liquids rise in capillary with meniscus concave upwards, like this figure 1. Similarly, non-wetting liquids fall in capillary with meniscus convex upwards, like this. This is the example in water and water-like liquids for which angle of contact is acute, and this is the case of mercury and mercury-like liquids for which angle of contact is obtuse. Next, for wetting liquids theta is acute, that is less than 90 degree. For non-wetting liquids angle of contact theta is obtuse, that is more than 90 degree. From this relation, for capillaries of different radius, from equation 1, for a given liquid, T, theta and density rho are constants, therefore H is inversely proportional to R. So H1 R1 is equal to H2 R2 is equal to constant. Next, angle of contact is 0 for clean water. Next, water rises in plant fibers due to capillarity. Now question 1, for different capillaries of different radii are the condition of liquid rise H is, these are the options as discussed before. For different capillaries of different radii, H is inversely proportional to R, therefore H into R is constant. So option B is the correct one. Next we take question number 2. The question is, water rises in a vertical capillary tube up to a height of 2 cm. When the tube is inclined 60 degree with the vertical, then up to what length water will rise in the tube? Solution to question 2. Here according to question, when the capillary tube is placed vertical in the liquid, like this, then rise of liquid in the capillary is H. According to question, this height H is equal to 2 centimeter. We have to find this length L. Angle of inclination of capillary tube with vertical is 60 degree. Therefore, cos 60 will be equal to base upon hypotenuse means H upon L, which gives L as H upon cos 60. H is 2 centimeter, so it is 2 upon cos 60 means 1 by 2. So it becomes 4 centimeter. So the correct option is C. Next question number 3. The question is, If the diameter of the capillary tube is doubled, then the height of the liquid that will rise is. Now solution to question 3. Here given diameter D2 is 2 D1. Therefore 2 R2 will be equal to 2 R1. 2 cancels out, which gives R2 is equal to 2 R1. Now H1 R1 is equal to H2 R2, which gives H2 as H1 R1 upon R2. H1 is H1. This is equal to H1 into R1 upon 2 R1, because R2 is equal to 2 R1. R1 cancels out and we get H2 as H1 upon 2. So the correct option is A, half. Next question number 4. The question is surface tension for pure water in a capillary tube experiment is. These are the options. Now solution to question 4. We know surface tension T is equal to R rho GH upon 2 cos theta. For pure water, theta is 0 degree. Therefore, above equation becomes T is equal to R rho G H upon 2, because cos 0 is 1. So the correct option is R rho G H upon 2, option B. Next question number 5. The question is when a capillary tube is dipped in water, water rises 0.005 meter in it. If the surface tension of water is 75 into 10 to minus 3 Newton per meter, then the radius of the capillary is. These are the options. Solution to question 5. We know surface tension T is equal to R rho G H upon 2 cos theta. Here for water theta is 0 degree, therefore it becomes R rho G H upon 2, because theta is equal to 0 degree for water, which gives R as 2T upon rho G H. Values are known. 2 into T is 75 into 10 to minus 3 upon rho. Water of density is 1000. G is 9.8 and H is given to be 0.005. After simplification it gives 1.02 into 10 to minus 3 meter, which is 1.02 millimeter or nearly 1 millimeter. This is nearly 1 millimeter. So the correct option is B, 1 mm. Next question number 6. The question is two capillary tubes of same diameter are put vertically in two different liquids with relative densities 0.8 and 0.6 respectively and surface tensions 60 and 50 dyne per cm respectively. The ratio of heights of liquids in the two tubes, that is H1 upon H2 is. Solution to question 6. We know surface tension T is equal to R rho GH upon 2 cos theta, which gives H as 2T cos theta upon R rho G. Therefore, H is directly proportional to T and inversely proportional to density, assuming theta same for the both liquids. Therefore, H1 upon H2 will be equal to T1 upon rho 1 upon T2 upon rho 2, which gives T1 upon T2 into rho 2 upon rho 1. T1 upon T2 is given to be 60 is to 50, and rho 2 upon rho 1 is equal to the ratio of their relative densities, which are 0.6 and 0.8. After simplification, we get the ratio as 9 upon 10. So the correct option is A. Next question number 7. The question is, a vessel whose bottom has a round hole of diameter 0.1 millimeter is filled with water. The maximum height to which the water can be filled without leakages. These are the options. Acceleration due to gravity is given to be 1000 cm per second square, and surface tension of water T is equal to 75 dyne per cm. Now solution to question 7. Suppose this is the vessel in which water has to be filled to the maximum height H max without leakage from the circular hole of diameter 0.1 millimeter at the bottom. So, D is equal to 0.1 millimeter, radius will be equal to D upon 2, which is equal to 0.005 centimeter. Now, T is equal to R rho G H upon 2 cos theta. For water, theta is 0, therefore it becomes R rho G H upon 2, T is equal to, which gives H as 2T upon R rho G. Now putting the corresponding values, we get H is equal to 2 into 75 upon R is 0.005, rho is density of water 1 gram per cm cube, and small g is 1000 centimeter per second square. On simplification, it gives 30 centimeter. So the correct option will be C. Next question number 8. The question is, the following observations were taken for determining surface tension of water by capillary method. Diameter D is equal to 1.25 into 10 to minus 2 meter. Rise of water H is equal to 1.45 into 10 to minus 2 meter. Using G is equal to 9.8 meter per second square, and the simplified relation T is equal to R GH into 10 to power 3 upon 2 Newton per meter. The possible error in the surface tension is closest to these are the options. Solution to question 8. Given diameter D is equal to 1.25 into 10 to minus 2 meter. Height of rise of water in the capillary is H is equal to 1.45 into 10 to minus 2 meter. Simplified G is constant to be given as 9.8 meter per second square. We have to find delta T upon T. Now, surface tension is given to be R H G into 10 to power 3, which is density of water, upon 2 Newton per meter. Therefore, delta T upon T will be equal to delta R upon R plus delta H upon H, which may be written as 2 delta R will be equal to 2 delta D and 2 R will be equal to D. So, it may be written as delta D upon D plus delta H upon H. So, delta D is the least count of this, which is 0.01 into 10 to power minus 2, and D is 1.25 10 to minus 2. Similarly, delta H is 0.01 into 10 to minus 2 upon H is 1.45 into 10 to minus 2. On simplification, it gives 0.0149, which may be written as 1.49%, which is nearly equal to 1.5, and therefore the correct option will be D. Next, question number 9. The question is, the radius of a capillary is 2 into 10 to minus 3 meter. A liquid of weight 6.28 into 10 to minus 4 Newton may remain in the capillary. The surface tension of liquid will be. These are the options. Now, solution to question 9. Here, for equilibrium, upward force due to surface tension must be equal to the downward weight of liquid. Therefore, downward weight mg will be equal to total upward force 2 pi r into t, which gives t as mg upon 2 pi r. mg is given to be 6.28 into 10 to minus 4 upon 2 pi may be written as 3.14. R is given to be 2 into 10 to minus 3. On simplification, it gives 0.5 into 10 to minus 1, which may be written as 5 into 10 to minus 2 Newton per meter. So, the correct option will be D. Next, question number 10. The question is, a capillary of radius r is placed in water and water rises to a height h in it. Mass of water in the capillary tube is m. If the radius is doubled, then the mass of water in the capillary will be. These are the options. Now, solution to question 10. For equilibrium, the upward force due to surface tension is equal to the downward weight of liquid in capillary. Therefore, m into g will be equal to 2 pi r into t, which means that r is directly proportional to m. Therefore, m upon m dash will be equal to r upon r dash, which is r upon 2r, because the radius has been doubled. So we get m dash equal to m into 2r by r, that is 2m. So the correct option will be B, 2m. Next question number 11. The question is, a liquid rises in a glass capillary to a height 1.8 centimeter. If another glass capillary of radius 90% of the radius of the first capillary is placed vertically in the same liquid, then the rise in this capillary will be. Now, solution to question 11. We know R1 H1 is equal to R2 H2. Therefore, R2 will be equal to R1 H1 upon R2, because R2 is given to be 90% of R1, that is 90 upon 100. R1, that is 0.9 R1. So it gives R1 into 1.8 upon 0.9 R1, which gives 2 centimeter. So the correct option will be B.